For the constant k, where k is greater than 1, the functions f and g are defined by f of x is equal to ln of x plus k, where x is greater than minus k, and g of x is equal to the modulus of 2x minus k, where x is a real number. Part A. On separate axes, sketch the graph of f and the graph of g. So let's start off with the graph of f. I'm first going to draw just the ln x function. So let me draw that first. Ln x, I know, looks something like this. I know it cuts through the point 1 here, and I know it has the line x equals 0 as an asymptote. Then it's got this, in this specific case here, we've got this plus k on the inside here. So the plus k on the inside of the function, that's going to move the graph k squares in the negative x direction. So the whole graph is going to move k squares over here. So the new asymptote would be here at x equals minus k. It's now going to cut through roughly here at 1 minus k. I do know that the point 1 will go past the y-axis because I was told that k is greater than 1. And therefore my graph is going to look something like this. Right, I do need to mark on where the graph meets the coordinate axes. I've obviously marked on where it meets the x-axis at 1 minus k. It's going to meet the y-axis when x equals 0. So if I substitute 0 into this function, I get ln of 0 plus k, which is just ln k. So that's where it meets the y-axis. So that is that's the graph of f of x. Now to draw the graph of g of x, I'm first going to draw the graph of 2x minus k. So that's got a y-intercept of minus k, and it's got a gradient of 2. So it's going to look something like this. This point here is where our graph equals 0. So that's where 2x equals k, or x equals k over 2. We want to do the modulus of this graph, however. So we want to take where the graph is negative, this part here, and make it positive. So that's now going to come up here like this, cutting through here at positive k. This part of the graph will stay exactly as it is. This coordinate here will still be k over 2. And we can now get rid of this. And there we go. That's my graph of 2x, the modulus of 2x minus k. That's part A done. Part B. Write down the range of f. Well, let's look at our f graph. The f graph went like this, remember? So what could y possibly be? Well, it looks at the lower end that y is going down and down and down and down. It doesn't seem like it's going to have any limit. It doesn't seem like it stops. It's just going to keep decreasing, decreasing, decreasing forever. So there's no lower limit for y. Upper limit for y, it goes up and up and up and up. And again, it would keep going. So there's no limits with regards to the range of the y. So I'm just going to say that f of x can be any real number. Part C. Find fg of k over 4. So this is saying to substitute k over 4 into the g function first, and then take the answer and substitute it into the f function. So let's do that. Let's substitute the k over 4 into the g function. So 2 times k over 4 minus k, and then the modulus of that. So 2 times k over 4 is k over 2 minus k. So I've got half k minus k, which is minus a half k. Then when we do the modulus of that, we'll get positive k over 2. So that's the answer I get when I substitute k over 4 into the g function. I now need to substitute that into the f function. So the f function is ln of x plus k. So ln of k over 2 plus k. K over 2 plus k is 3k over 2. And that's pretty much the simplest form that I can give my answer in. So that's my answer for part C. Then for part D, the curve C has the equation y equals f of x. The tangent to C at the point with x coordinate 3 is parallel to the line with the equation 9y equals 2x plus 1. Right, so if it's parallel to this, it has the same gradient. So let's think, what's the gradient of this line? Let's rearrange, so divide both sides by 9. So the gradient of this line is 2/9, which means the gradient of my tangent when x is 3 is going to have a gradient of 2/9. So let's get the gradient function for our f of x. So take our f of x function and let's differentiate that to get the gradient function. So ln will differentiate to be 1 over. So 1 over the x plus k. Just double check to see if we need to use the chain rule. No, we don't, because the derivative of x plus k is just 1. So this is our gradient function. And when x is 3, this should equal 2/9. So when x is 3, so 1 over 3 plus k, this should equal 2/9. Different ways we can solve this equation. I'm going to times the left-hand side by 2, so that I get 2 over 6 plus 2k is equal to 2 over 9. That way I've got the same numerator, which means the denominators must be the same, and I can just write that down. 6 plus 2k equals 9, so 2k equals 3, so k is 1.5. And we're done.